Hello friends, welcome to my channel. Let's have a look at problem 21, merge two sorted linked list. So in this video, we're going to practice the use of dummy node and simple comparison. So first, I'll read through the statement of the problem, and then we will analyze the problem, and finally share the code. First, let's look at the statement of this problem. So we are given the height of two sorted linked lists called list 1 and list 2. So merge the two lists in one sorted list. So the list should be made by splicing together the nodes of the first two lists. So we are required to return the height of the merged linked list. So here are several examples. So both example 2 and example 3 are actually edge cases. So let's focus on example 1. So in example 1, so we have two linked lists, 1, 2, 4, and 1, 3, 4. And then after the merge, so the corresponding array is 1, 1, 2, 3, 4, 4. So that's example 1. So before we write the code, let's first look at the constraints on this problem, or we can regard this as additional assumption. First, the number of nodes in both lists is in the range from 0 to 50, so it's a closed interval. Secondly, the value of the nodes is bounded by 100 in absolute value. And the third one is that both list 1 and list 2 are sorted in non-decreasing order. So this is actually an important assumption. So with that said, let's look at the method we're going to share here. So here the method basically is mimicking the treatment for merging two array. So basically, because we are here facing a linked list, we're going to use a dummy node for convenience. So this is actually a detail, but this actually can be helpful or convenient. So another thing is do comparison, right? So the idea is the following. So we initialize a dummy node, and then we connect this dummy node with the smaller height each time among list 1 and list 2 in the process. So as we mentioned, so this problem can be regarded as the linked list version of merge two sorted numerical arrays. For example, let's merge 1, 3, 5 or 2 and 2, 4, 6. Same operations for the merge. So with that said, I guess we're ready to write the code. So first, because we are going to use the dummy node, let me initialize a dummy node. So the dummy node will be a list node. Let's call this constructor. So here the value. So I'm going to specify a value. Let's see, -101, because the value is in between -100 and +100. Let's put here just for convenience. So then I'm going to use a new variable called current to pointing to dummy. And then let's do the merge. So the merge is actually a while loop, while list 1 or list 2, right? So if one of them is not null, so we can continue the process. So we are going to consider several cases. First, if list 1 and list 2, right? If both the two nodes or the corresponding two linked lists are not null, then we can consider two cases. First is that if list 1 value is less than list 2 value. So notice that here list 1 and list 2, we should reinterpret them as the head nodes. So if this is the thing, we're going to connect the current with the list 1, right? So first, let's get list 1 next for moving forward. So let's call list 1 next. And then what we're going to do is that we let current next to be the list 1 height, right? So that's what we want to do. And then we are going to push the current to list 1 step further. And then we reset the height of the list 1 to be list 1 next, so which we have restored for access, right? So this is the one case if list 1 value is less than list2 value. All the other cases actually are absorbed in the else block. For example, if list1 value equals list2 value, so we can do either first. But this case in the else block will absorb all the cases. For this case, first let me get list2 next, actually parallel to this block. So it's list2 next, and then so we're going to set the current next to be list2, and then we move the current one step further, so that is list2, and then we set list2 to be the list2 next we have stored for access. So that's it for this case. If both the list1 and list2 are not null, or the corresponding heights are not null. So other cases, the complementary of this condition is that either list1 is null or list2 is null. So actually this case is very easy to treat. So if list1, so in other words, list2 is empty. So what we need to do is that just connect the current with list1. That's it. So we're going to do the break. Another case is that if we have list2. So in this case, so we're going to connect the current next with list2 and then do the break. So that's all the cases. Actually, if both list1 and list2 are null, so actually it violates the while check condition. So we actually exit the while loop. So with that said, so we are ready to return the dummy next. So that's the full solution format. Here we want to present. So notice that this format of writing actually is in the iterative format. So for this problem, for sure, we can write in a recursive format. But for understanding the details, we write here an iterative format. So with that said, let's first do a special case check. Yeah, it passes the first example. So now let's do the generic case check directly. Yeah, it passes all the generic cases. So I guess that's about it for this solution to the problem. So here we want to emphasize that so the use of a dummy node is not absolutely necessary, but if we choose to use it, it can be convenient in some cases. So with that said, I guess that's the end of this video. Thank you very much.